Today we're going to do a crash course on RecBole, a Python framework built on top of PyTorch that allows us to easily work with state-of-the-art recommender systems or recommender system architectures. So the idea is you have a data set, you want to do sequential recommendation, context-aware recommendation, knowledge-based recommendation, or something else, and you don't want to implement the whole architecture that you want to use, for example, BERT4rec or SASRec yourself. You can just use RecBole instead. It already has 94 models in it, and you can easily apply them to your custom datasets. So this is quite a niche topic, but I think it's very interesting for those of you guys who build recommender systems. So if you like this video and if you get value out of it, let me know by hitting the like button and subscribing. And now let us get right into it. Alright, so we're going to do a crash course on RecBole. As always with my crash courses, we're going to focus on speed and simplicity. So we're going to go through practical examples that showcase how RecBole is used. We're not going to go through every model, every data set, every customization option. I'm going to show you the gist of it, and then you can take it from there, use the documentation to adjust it to your specific use case. The general idea of RecBole is that you want to use, or you want to build recommender systems. You want to use the state-of-the-art models. You want to use models like BERT4rec, for example. You want to use models like SASRec, for example, which are defined in papers. You can take a look at the architecture, and you could go ahead and implement them yourself in PyTorch. But what you want to do instead here with RecBole is you can just use the models that are provided to you or for you in the model list. So depending on your task here, you can look up the various models. If I'm interested in SASRec, for example, which is oftentimes the state of the art when it comes to sequential recommendation, I can just get this model from RecBole easily. In addition to that, we're not going to make use of this too much. We also have data sets. So in RecBole, we also have ready to go data sets that we don't have to download and pre-process ourselves. I'm just going to show this as a Hello World example, but then we're going to take our own data set from Kaggle and work with this one, just because, of course, if you're going to use this package, you're not going to use it on a sample data set. Usually you're going to use it on your own data. But here, for example, you could go with the movie lens data set. If you want to use this with RecBole, it's the ML 100K. If you want to go with the small version, you also have larger versions. You just need the identifier, and then you can use this dataset in RecBole. How this is done, we're going to cover that here in a second, but this is the general outline here. This is what RecBole is for. It's for people working with recommender systems, building recommender systems, training recommender systems, evaluating them, and you don't want to do it yourself. You don't want to implement all these architectures from scratch in PyTorch. Now, before we can jump right into the practical part, we need to set up the environment first, so install RecBole onto our system. For this, I'm going to open up a terminal, navigate to my tutorial directory, and here I'm going to use UV as my package manager. You can do that directly with pip or pip3 install if you want to. I'm a fan of UV, so I'm going to say UV init and then -- no package to make sure that this is actually just a simple main py file that is created here. And here I'm going to say, first of all, UV add RecBole. And there can be some issues with the versions of things that you install. You're going to notice that when you try to run something. For me, what fixes it before we even run into the problem is to say UV add numpy has to be less than 2. And of course, I need to put this into quotations, otherwise it's not going to work. Then I also have to say UV add k-means -pytorch. This is also required. And then also UV add ray tune. Now, these were the things that I had to install to make it work on my system. Speaking of my system, I'm doing this here now in my terminal on my desktop PC to show you the steps. This is how you install it. You can reproduce this on your own system. However, I'm going to run this actually now. I'm going to connect now using SSH to my other device. This is not relevant to you. I'm just explaining the setup so you're not confused. I'm going to SSH into my Dell Pro Max. This is this device here, an implementation of the DGX Spark, just a home AI station for prototyping and playing around with large models. It has 128 gigabytes of shared memory, which is just better for what we're doing here. So I'm just going to connect to this system. However, if you're working on your desktop, if you're working on your laptop, on any other device, you don't have to concern yourself with what I'm doing here. I'm just explaining what I'm doing. I'm connecting here using VS Code to my device, and there I can run RecBole. So here I have now VS Code opened up. I can go into the terminal and I can go to documents and create a new directory. Let's call this RecBole tutorial. I'm going to go into RecBole tutorial here, and I'm going to do the same thing, UV init, UV add, and it's going to be RecBole first, then numpy less than 2. So numpy below version 2 essentially. Then also k-means PyTorch, and then finally, as we said, ray tune. And if there's any other problem, we're going to fix it as it comes up. But that is the setup that worked for me. And now what we're going to do is we're going to write the hello world example of RecBole. So I'm going to close the terminal here. I'm going to go to my tutorial directory. I'm going to create a new file and call it main.py, or actually we do already have a main.py because we did uv init. I'm going to remove the code here and we're going to start from scratch. I'm going to say from recbole.quickstart, and let me also go into full screen here, import run RecBole. This is the easiest way to run RecBole. Just use this function, provide the model, provide the data set, and it's going to work. So for the hello world example, I'm just going to use a model and a data set that's already part of RecBole. We don't need to do anything else. So I'm just going to call run RecBole. I'm going to specify the model is going to be bird for rec. The data set is going to be equal to ML movie lens 100K, so the small movie lens data set. And the most important thing, the most complex thing here is the config dictionary. We can keep it minimal, but this is where you set up everything. Also like the hidden size, the embedding size, how you want to split the data, what kind of hyperparameters you want to set. But we're going to keep it super simple. I'm just going to say epochs is going to be equal to, and of course I need to make this a string. Epochs is going to be equal to 5, let's say. So we want to do 5 epochs of training. And then for bird4rec and sasrec, we need to provide train negative samples. Arguments is going to be none. This is just required for this one. That is the simplest thing that we can do. So I'm going to open up a terminal and I'm going to say uv run and main py. And now you can see that this is actually important because I got an error because this is missing. It's missing because I mistyped the name here. It's sample arcs, not samples arcs. So that is the issue here. And now it starts training on the movie lens dataset with bird4rec. Now you're going to see that this is going to work. We're also going to get the validation metrics, but in the end it's going to fail because of a dependency mismatch. There's a lot of stuff that you can do here. You can downgrade the Python version. You can fix stuff yourself in the code. We're just going to go the super simple way because there's going to be a problem due to a version mismatch. We're going to not have a default parameter set. We're just going to provide an environment flag to circumvent this. So here you can see waits only load failed. In PyTorch 2.6, we changed the default value from false to true. So what we can do is we can just set an environment variable. I can just say import OS, and then I'm going to say OS environ to get the environment variable. And then I'm going to say torch force no waits only load, and that has to be set to 1. That is going to do that without us having to alter the PyTorch or RecBole code. Because otherwise, we either have to change the RecBole implementation or the PyTorch implementation, or we have to downgrade PyTorch. I don't want to deal with that, so this is what I'm going to do here. But the rest worked. You can see that we trained, we have the hit rate, we have the mean reciprocal rank, the recall, all these metrics that we care about when it comes to recommender systems. We have them here epoch by epoch, and in the end it failed to just export this model. So let's maybe go with 2 epochs now and run this again to see that it can actually save the final model. And there you go, we have the evaluation and we finish without any errors. We get the test results with a hit rate at 10, which is quite low, but we only did it for 2 epochs. And that is basically the most simple thing you can do if the model and the data set are already part of RecBole. So if you want to do some benchmarking or some hyperparameter tuning on existing data sets here, you can do it like this. If you want to include your own data, you have to do some more work. So now what we're going to do is we're going to take a look at this data set here, Retail Rocket Recommender System dataset. To be precise, we're only going to take a look at the events CSV. We're going to keep it super simple here because this is actually a data set that contains visitor IDs across longer time periods. So this is not session-based recommendation, but we're going to turn it into session-based recommendation. The difference here being in session-based recommendation, you don't really have a user profile. So you don't have one user that has multiple sessions over time. You don't have a profile about that user with preferences. You just have a session that is happening right now. User is clicking something. You want to know what the user is going to click next. So if a user has multiple sessions over time, let's say 1 session today, 1 session tomorrow, we're going to treat those as separate users. Even though the visitor ID is the same, we're going to say these are different sessions. So we're going to be blind to the user behavior overall. We're going to only focus on this session behavior. So we're going to turn this dataset, this events CSV file, into a session-based recommendation task. So for this, we're going to go to download. I'm going to use curl to keep it simple. So I'm just going to copy this command. I'm going to go here into my command line and I'm going to say copy paste. The only thing is I don't want to download this to downloads, or actually I can just download it to downloads and then move it into this directory here. There you go. Download is finished. We can say make directory data, and then I can say move from downloads, actually /downloads here, and then what was it called? E-commerce dataset zip. We're going to move it to data. In data here, we're going to say unzip e-commerce dataset. And from those files here, we're only interested in events CSV. Now to take a look at the data, I'm going to also briefly install Jupyter Lab. So I'm going to say uv add Jupyter Lab and also Jupyter Lab-vim, just so I have my keybinds in there. And then I'm going to say uv run Jupyter Lab. I have this tunneled properly, so this is gonna actually open up here in VS Code. I didn't want that. I want to open this in my browser like this. So now I have it here in my browser, and I can open a notebook. Let's call this main IPYNB. I'm gonna import pandas as PD, and I'm gonna say data frame is equal to pandas read CSV, and I want to read the data events CSV file. Let's take a look at this data frame. We basically have a timestamp, a visitor ID, which is the user identifier, event view. We can also take a look at what other events exist. So I'm going to say event dot value counts. This is going to show me what kind of events I have. Add to cart transaction. So you can of course also make the task more interesting by predicting what is added to the cart. We're going to keep it super simple. We're only going to focus on what is the user going to click next. So I want to filter the data frame so that the only type of data I have in there is where event is equal to view. We're not going to do the pre-processing here in a notebook, but this is what we're going to do. By doing this, we lose a little bit of data, but not really a lot of data. We have still 2.6 million rows. And we're also not interested in the transaction ID. The only thing is we need a user, we need an item, and we need a timestamp so that we have an order. And the idea is we have a user session and a user clicks certain items. Our task is to predict the next item that is being clicked. So to maybe describe what we're going to model here conceptually, first of all, we're going to drop all the sessions where a user doesn't click on at least 5 items. We need to have at least 5 items, A, B, C, D, E. Let's say we also have F, and our task will be to model this. Our model is going to get A and has to predict B. So the model in the beginning, let me also make this a markdown cell here. The model is going to start with A and has to predict B. Then the model is going to take A and B and it has to predict C, and so on and so forth. And then we can use A, B, C, D and predicting E as the validation task. And we can use A, B, C, D, E and predicting F as the actual testing set, as the actual test task. Now, theoretically, you can also have a different setup where you say, I want to use the first 80% of sessions for training, and then I want to predict on the last 20%. This would be a different split. We're going to do this split today where we just train the model to predict the last click of a session. So that is going to be our setup. So let us close the notebook. For this, I'm going to implement a preparation script. I'm going to create a new script here called prepare.py. This is going to contain the logic that is required to take the raw CSV dataset and turn it into a format that RecBole can handle. So I'm going to say here, import pandas as PD. Also, I'm going to say import OS because we're going to create some directories. Then I'm going to say data frame is equal to PD read CSV, and we're going to read again the data / events.csv. Then, as I mentioned, we only want to keep the rows where the event is actually equal to view. We're only interested in the clicks, and we're going to sort the results here, sort values by first of all the visitor ID, because I want to group, so visitor ID, and within that visitor ID I want to sort by timestamp. And with this data now, I want to split the user clicks into individual sessions. So if user A clicks something yesterday at, let's say 10:30, and then user A clicks yesterday at 10:32, that should be considered the same session. But if user A clicks something today, let's say at 15:34, and then something again at 35 or something, that should also be the same session, but a different session in this one. So I want to actually treat these two, so these two, and then also if I have A today 15:35, I want to treat those as 2 different sessions. That's the idea. So this is going to be one user and that's going to be another user. We're completely blind to the fact that this is the same A. We're going to not think about this. So we're doing really session-based recommendation, not just sequential recommendation. And to do this properly, we need to define a threshold. We need to say that everything, if the last click is more than 30 minutes ago, for example, this is going to be our threshold here. We're going to consider this another session. So if A today clicked something at 15 o'clock, that would be a different session. So this would be a session, and this would be a session, and this would be a session. That's the idea. But for that, we need to calculate, first of all, the gaps between the clicks. So I'm going to say gaps is equal to data frame group by, we want to group by the visitor ID. So visitor ID, and we want to get the timestamp and do a diff calculation. So for every row now, we're going to have the difference between the last timestamp and this timestamp, considering it's in the same group. So for the first entry, we're always going to have a nan value because we don't have a previous click for this user if it's the first one. So to calculate the session number per user, we're going to use the gaps threshold. And every time we cross it, or every time we have a nan value, we're going to know that this is a new session. So we can just sum up every time this happens to get the session number. So what I'm going to say is I'm going to say df session is equal to, and I'm gonna use gaps.isNA. That is gonna be one condition, or what's also possible, our gap or our gaps go beyond. Maybe we should use singular here. So let's go with gap instead of gaps. If the gap is greater than 30 minutes, so 30 times 60 seconds, which is 1000 milliseconds, because we need to provide that in milliseconds because the timestamp is in milliseconds. If one of the two is the case, then the threshold was crossed. So I'm going to take this group by the visitor ID. And actually for this to work, I need to say df.visitorID because we're not targeting the data frame right now. And with all this now, we're going to apply the cumulative sum. And then basically we're going to define a new user ID. This is the one that we're actually going to use. And that is actually going to be a session identifier, not a user identifier. It's going to combine the visitor ID with the session number. So, or with the session ID. So I'm going to say here df visitor ID as type string. And then we're going to add an underscore. And we're going to say df session. Actually, let's keep it consistent. Let's use also session like this here as type string. So now we don't have users anymore. Now we have sessions. The next thing is we want to get rid of all the sessions that don't have at least 5 clicks. So I'm going to say df is equal to df group by. I want to group by this newly created user ID. So by the session ID actually. And I want to filter lambda x, which is the result of grouping. The length of x has to be greater than 5. So we have at least 5 entries in this group. And then the rest is just putting it into the right format for RecBole. So we're going to say the output is going to be the data frame. We're going to select only the columns that we need. We need the user ID, we need the item ID, and we need the timestamp. These are the things we're going to use. And we can also then say that the columns have to be renamed because we have certain conventions for RecBole. The user ID token has to be specified as user ID token. The item ID has to be item underscore ID, also with token. And the timestamp is a float, so timestamp colon float. This is just how you have to specify it for RecBole. Then finally, we're going to say os make directories. And I'm going to specify here data/retail rocket exist OK is equal to true. And then we're going to say out.toCSV data retail rocket dot inter for interaction. The separator for RecBole is tab, so \t, and we're going to say index is equal to false. So if I didn't make any typos here or any conceptual mistakes, we should be able to open up a new terminal here, navigate again to Documents, RecBole Tutorial, and do a UV run prepare. But of course, I made a small mistake here because it has to be df in front of this condition. Otherwise, we're just specifying the condition itself without the data frame being used as databases. And there you go, it finished successfully. So now I have in my data directory here, retail rocket and the inter file, which I'm not going to open because it's quite large. So this is the code that we use to get the data into the right format for RecBole. To now actually train on this data set, we need to go back to main PY and adjust some things. First of all, the data set is no longer ML100K. It's actually our retail rocket. So we can just call it retail rocket. Why is this possible? Because we're going to specify data as the data path, and then it's going to realize there's a retail rocket directory with retail rocket.inter in it. So this is something that we're going to put into the config dictionary. We're going to say data path is the data directory in this directory. Let's keep the epochs at 2 for testing. We're going to also keep this here. Then we're also going to specify some settings when it comes to evaluation. So eval args is going to be defined here as a dictionary. And here we're going to define, for example, how we split the data. So in this dictionary, the first key is going to be split, and it's going to point to yet another dictionary, which is going to have ls, which stands for leave one out split. And we can say here valid underscore and underscore test. This is basically the idea I illustrated before. We have A, B, C, D. Predicting E is going to be the task for validation. And A, B, C, D, E. Predicting F is going to be the task for testing. This is what leave one out split means. And this is what valid and test means. We're going to do that for validation and for testing. Then also important, the order of our split is going to be time oriented. So time order. So we're going to say order is TO for time order. We're going to also group by user. So group underscore by is going to be user, which means that this split is going to happen within the user, within the session. And then we're going to say mode is equal to full, which means that we're going to rank against all the items. We're going to consider the full catalog, and hopefully our true result will be in the 10 recommended ones. And then finally, we need to specify here load columns. So load call, and that's going to be a dictionary. And we're going to say interaction or inter, and it's going to be user ID, item ID, and timestamp. And that's basically all the magic. So what we can do now is we can go into the terminal. We can say uv run main py, and this is going to run BERT4rec and train it on this custom data set that we loaded for 2 epochs. So as you can see here, it's training. You can also see how much GPU RAM it is actually using, 18.33 gigabytes out of 120 gigabytes of shared memory. And once the training is done, we again get the final result here for the test set. We get a hit rate at 10 of 1.68%, which means that we do 10 recommendations, we make 10 recommendations, and in 1.68% of sessions, among those 10 recommendations, we have the correct one, the correct item that is being clicked. Now, 2 epochs is not a lot, so we should not be judging BERT4rec too early. Oftentimes, it takes more time with those larger models to get to the same level of performance as with smaller ones, but sometimes the ceiling is a bit higher, so we can go beyond the limit of something more simple. So what I want to do now is I want to compare BERT4rec to SASRec with a couple of epochs, and I also want to compare it to a basic PyTorch model. So I have here a torch prepare script. This basically just takes our data set and turns it into the same format of taking A, B predicting C, A, B, C predicting D, and reserving the last one for testing and the second last one for validation. Absolutely same idea. We're just storing this as data for our PyTorch model. And then we use torch train, which is a very, very simple LSTM network. We literally just have an embedding layer, LSTM layer, linear layer, fully connected one. And that's basically it. Nothing too fancy. We're just training and evaluating here on the same metrics. And we want to see how much better this torch model, which is very simple, performs compared to SASRec and BERT4rec. So what I'm going to do now is I'm going to say uv run torch prepare. I'm not covering this code in detail because the tutorial is about RecBole and not about PyTorch. So now I'm going to also say torch train here, and this is giving me already for the first epoch the validation scores. But before we continue with that, I actually want to abort and make this only 10 epochs so that we don't have to sit for too long here. So I'm going to train for 10 epochs here, 10 epochs BERT4rec, and 10 epochs SASRec. Now the PyTorch model finished training. We can see it has a hit rate at 10 on the test set, on the evaluation set of 33.81%. This is much better than what BERT4rec produced after 2 epochs. And even if we go up here to epoch 2, you can see that on the validation set, we already get a hit rate of 12%. So this seems to be faster, at least, than BERT4rec. Let's go to BERT4rec, to our main script here, and say we want to also train for 10 epochs. So then we're going to do uv run main py again. And this took quite some time, but after 10 epochs, we can see we end up with a hit rate at 10 of around 26.11%. So this is still worse than our simple LSTM model. The thing is, the data is not really complex. Usually BERT4rec outperforms basic PyTorch LSTM architectures, but oftentimes it takes more time to converge to that optimum to get to the actual potential. So this here is not really strong. I also did that for 20 epochs in the preparation for this video, and there it also underperformed the LSTM slightly, not too much, but slightly after 20 epochs. However, SASRec is usually very, very powerful. So let's go, and the only thing we're going to do now is we're going to say SASRec, because this is the model that usually outperforms most other alternative approaches. This is actually also part of my master thesis. Let me run this here. That I'm comparing currently. I mean, actually, I'm doing this thesis for quite some time already, but I'm comparing BERT4X, SASRec, and a novel approach that I'm trying to pursue or to see if it works better. First of all, you can see this is much faster. Also, you can see it uses less VRAM, and it will outperform the PyTorch model and also BERT4X. And what I wanted to say about the master thesis is that SASRec is really the strongest baseline that I have at the moment. And there you go. After 10 epochs of SASRec, we get a hit rate at 10 of 44.52%. So massively outperforming both BERT4X and also the simple PyTorch model. Probably if we take a look at the values over time, they're also increasing. So probably if we go with 20 epochs, 30 epochs, we could even get a better performance, but you can see that SASRec is the winner here. But the last thing I want to cover here is how do we take this trained model now and use it for inference? Because you can see it always saves the checkpoints. We also have the final model saved in our saved directory. So here is our tutorial directory. Down here we have saved. And in here we have the different checkpoints and final models. How do we actually use this model now for inference on new data? For this, I'm going to create a new file now called Inference py. So Inference py is just going to load this checkpoint. We're going to say import OS. We're going to set the environment variable again. Then I'm going to say import torch. I'm going to say from RecBole.quickstart. I'm going to import load data and model, and then from RecBole data interaction, I'm going to import the class interaction. So we can load everything we need from the file that is saved from the PyTorch file. So I'm going to say config model dataset, and then everything else unpacked is going to be equal to load data and model. And here we now just put the path to the PyTorch file. So right click, copy relative path. I can paste it here. This is not relative enough, so I actually only want to have saved and then the PyTorch file. Then I can come up with some random numbers. For this, you can either just use the ones that I provide here, or if you want to generate some random ones yourself. The important thing is they have to be part of the catalog. So what I'm going to do here is I'm going to go back to my terminal. I'm going to run JupyterLab again. And the reason I'm doing this is because I need to recreate the data set and get some random IDs that I can use here. Because if I don't do that, I will maybe use IDs that don't exist and I will get an error. So instead, I'm going to JupyterLab here. I'm going to open up my notebook again. I'm going to open up the prepare py file, and I need to get to this point here, I think. And I can just go into the notebook, create a new cell down here. And of course, don't forget the imports. So we need to also paste them here, import OS and import pandas SPD. And then with this data, I need to just say df item ID sample and however many I want to use. Let's go with 5. So now I'm going to use 5 IDs. I can just take these IDs here. I can put them as history. So just copy this ID, paste it here, copy the next ID, and so on and so forth. So now I can close this again. This is what I needed. So now I have some random IDs here that don't really belong together. So these are just clicks a user makes. And the question is, what is going to be the next click? I want my trained SASRec model to recommend items. Now for this, what I need to do is I need to take these tokens and turn them into IDs. So I'm going to say IDs is equal to dataset. This is what we return here from load data and model dot token to ID. I'm going to provide item ID. This is the field I'm targeting. And I'm going to pass the history list. So this is going to give me the IDs that I can actually feed into the trained model. Now, of course, I need to turn all of this into a tensor. So I'm going to say torch.tensor and then a list here with IDs. The device that is supposed to be used is just going to be config device. And then I also need a length variable here. So I'm just going to copy this. I'm going to call it length, and it's going to be the length of IDs. And that whole thing has to be in a list itself so that we have the right dimensionality and shape. Now for the interaction, we're going to say that this is equal to interaction, and that's going to take in a dictionary with item ID list, that's going to be X, and then the item length, which is going to be the length. And then basically with torch.noGradient, we're going to make the prediction. This is the model.full_sort_predict on the interaction. We're going to squeeze the result, and all of this will be stored in scores. And then we need to get the top 10. The top 10 is going to be scores.top k10. We want to have the indices, and we want to get them back to the CPU so we can work with them. And then finally, I need to turn them back into tokens, so into item IDs. And for that, I'm going to say result and colon maybe. And then I'm just going to go with dataset dot what do we have now? ID to token. We're going to provide item ID, and we're going to provide the top 10. So let's see if this actually works. We're going to open up a new terminal. I'm going to go again to documents and RecBole tutorial, and I'm going to say UV run, and it's the Inference PY. There you go. Everything boots up correctly, and it makes this prediction. So these are the top K recommendations, the top 10 recommendations for this sequence of clicks. What is going to be the next item? These are the guesses that the model, or the predictions that the model makes. So yeah, that's basically what I wanted to cover today. Of course, there's much more that you can do here. You can customize the models if you want to. You can customize the trainers. You can customize data loaders. There's a lot of stuff that you can do here if you want to go deeper into that. If this video performs very well, if you guys are crazy about recommender systems, I might go deeper into that. Otherwise, this is just a quick start crash course, and you can go deeper by using the documentation. So that's it for this video today. I hope you enjoyed it and hope you learned something. If so, let me know by hitting a like button and leaving a comment in the comment section down below. Also, in case you're interested, on my website, you will find a services tab and a tutoring tab. There you can contact me if you need help with a project, if you need a freelancer, a consultant. You will find my contact details via LinkedIn or email at the bottom of both pages. Besides that, don't forget to subscribe to this channel and hit the notification bell to not miss a single future video for free. Other than that, thank you much for watching, see you in the next video, and bye.